Overview of the motion estimation in the new HEVC search algorithm, used in HEVC process, includes 4 distinct main stages in order to determine the best motion vector. Motion estimation process. These stages, which are the motion vector prediction, MVP, the first search performed with a pattern of square or diamond forms, the refinement, and the raster search, are described in the next subsections. To compute the corresponding block's median predictor, the TZS algorithm uses the up predictor, the upper right predictor, and the left predictor. MV adjacent of a current POO. The median computation is done via the following equation. The first search is performed by the determination of the search pattern and the search range. As it is detailed in A and B, the main goal of this stage is to localize the search window via a pattern of square or a diamond forms. Diamond/square search pattern. A. Diamond search pattern stride length equal to 4. B. Square search pattern stride length equal to 4. Thus, these two search patterns are referred to the 8 points for each round. The distance corresponding to the minimum distortion point is saved in the best distance variable. Currently, diamond search pattern is used as default, but the square pattern search can also be used by modifying the HEV configuration file through the diamond search variable. This step consists of choosing the distance which corresponds to the greatest matched point from the previous search. 3 cases according to this distance denoted as best distance are summarized as follows. The process is stopped when best distance equals 0. A refinement is needed when 1. Digital imaging. This course is brought to you by Gilad James Mystery School. Learn more at giladjames.com. Introduction. An image would be called as an analog image if its pictorial representation can be represented in analog wave formats, whereas an image would be called as a digital image if its pictorial representation can be represented or stored in the data in digital form. Similarly, field of image processing can be categorized into digital image processing and analog image processing. Digital image processing, or digital imaging, in the area of computer science today, is defined as processing digital images through some algorithms using digital computers, whereas, analog image processing is any image processing task that can be conducted on two-dimensional analog signals by analog means. After the invention of digital computers, digital image processing took various advantages over analog image processing. A broad range of techniques and methods, in the form of a variety of algorithms, came into existence. One can find a rich literature today which can be applied to the input image data to solve various problems. These problems may include converting images into digital data, calibration, removing the buildup of noise and distortion during processing, etc. Since images are defined over 2 dimensions, and perhaps more, digital image processing may be modeled in the form of multidimensional systems. Digital image processing has evolved rapidly with the development of computers, mathematics, and the real-life demand for a variety of applications in wide range of areas. In the current age and time, digital imaging is used widely in various real-life applications. There is a number of potential digital imaging applications that include different areas such as environment, industry, medical science, agriculture, military, film, television, photography, robotics, remote sensing, medical diagnosis, reconnaissance, architectural and engineering design, art, crime prevention, geographical information systems, communication, intellectual property, retail catalogs, nudity detection, face finding, industrial applications, and others. The increasing trends, needs, and applications of imaging make it more difficult to process images for desired objectives. This leads to the idea of capturing, storing, finding, retrieving, analyzing, and using images in everyday life under the computing environment. Being a computer-based technology, digital imaging carries out automatic processing, manipulation, and interpretation of visual information. It plays a significant and important role in various aspects of real life. It is also highly useful in many areas, disciplines and fields of art, and science and technology. This lecture is specifically dedicated to digital imaging history, methodologies, tasks, software, and applications.